Okay, so we're asked to find dy over dx implicitly. So nobody can solve this for y, right? So I will differentiate the left-hand side. I will differentiate the right-hand side. I'm coming back to this. I did not forget. So this is function 1 and this is function 2. 2x prime is 2 times y prime plus 2x times y squared prime to y dy over dx. Do we agree so far? Minus e to the x prime is e to the x times arc sine y, which is the same with sine inverse y. The reason why I like to type arc sine is because I don't have to put the power. So it's easier to type arc sine than sine inverse. And then minus again, because there is a minus in front, e to the x times arc sine or sine inverse prime, which is 1 over the square of 1 minus y squared multiplied by y prime, which is dy over dx. That equals 14x. So there are two products. 2x prime is 2 times y squared plus 2x times 2y dy over dx. Now this is another product where this is function 1 and this is function 2. E to the x prime is e to the x times the arc sine and minus e to the x times arc sine y. But arc sine 1 prime is 1 over the square root of 1 minus y squared. This is what we just wrote a few minutes ago. This. But since it's not x, but it's a function y, I have to differentiate it, which is dy over dx. So now I have this. They will stay where they are, but this will move and this will move to the other side. So I will factor out dy over dx. In parentheses, I have 4xy minus e to the x over the square root of 1 minus y squared, and these are these two terms. They are accounted for now, equals 14x. I bring this negative 2y squared, and I bring this positive e to the x arc sine y. And the final step, dy over dx equals all this, 14x minus 2y squared plus e to the x arc sine y over this. Okay?
Screwed with my signs.
That's okay. That's okay. So that's final. Yes, I have to agree, it's ugly. But there were just two products in there. Okay, so now I would like us to determine the limit as x approaches 0 from 1 plus x raised to 1 over x. When I'm asked to find such a limit, what do I have to do first?
Okay, plug it in.
Yes. So this is 1. And 1 over x,
It's infinity.
right. Okay. This is another indeterminate case. Let's review the other three that we know already. Very good. It's very good.
Infinity over infinity.
Very good. This is number 4. Okay? This is 1 to infinity. Okay? I'll write full stop for a moment. And then I will say let y be 1 plus x raised to 1 over x. What do you think I'm going to do to both sides?
Natural log.
Absolutely. So I apply natural log to the left. And what do I get on the right-hand side? Now I'm going to find limit from natural log y as x approaches 0. And you should say, wait a minute. Wait a minute. This is not what you're asked to determine. You're asked to determine limit of y, but you are determining limit of natural log y. Correct? Right? A long time ago when we talked about continuity, we said that I am allowed, under certain conditions, I'm allowed to swap these two operators. But I'm not going to do it now. So right now, I know what I have to determine. I know that I'm determining something else. So I'm just going to, for now, ask you to bear with me. Okay? Good. So then this is limit. X approaches 0 from natural log, because it's natural log y, right? I'm sorry, 1 over x. Natural log of 1 plus x. Now, x approaches 0. I'm trying to find the limit of this. What is the first thing I have to find out? See, this is something different than this, right? So I guess I would say I'm starting it from scratch again.
So you still gotta plug it in.
Right. So let's see what we get. I get 0 over 0. Natural log 1 is 0. So 0 over 0. Oh, I like it. Why do I like it?
Because you can work and do something else to it.
Because I can apply what to it? L'Hopital. It's 0 over 0. So then I have limit as x approaches 0. Can anyone give us the derivative of the top as if the top is alone by itself?
1 over 1 plus x.
Can anyone give us the derivative of the denominator as if the denominator is by itself? So can you please plug in 0 again and tell me what you get? 1. I'm going to read the top, the starting and the end. I'm going to write them just without the middle part. So limit as x approaches 0 from natural log y is 1. Y is a function that is continuous. So I am allowed to do this. If you remember a long time ago, I said, please remember this because I need it a lot. So I'm going to do this, natural log of limit of y as x approaches 0 equals 1. And now I'm going to ask myself, oh, what can this be? Natural log of blah is 1.
Natural log of e is 1.
Exactly. So then the conclusion is clear. Limit as x approaches 0 from 1 plus x over 1 over x must be and this is one result, extremely important. Limit as x approaches 0 from 1 plus x to 1 over x is e. Actually, you determine it. I didn't. Okay? Here's the second case. How can I be on page 2 when I already have 3 pages? I don't know. Anyway, so I'm going to continue with 3.
But e is also just the inverse.
Euler's number.
Of,
It's Euler's number. And it's so important that it's right here in the calculator. Right here. Where you see division. So let's turn on the calculators, clear, whatever. So second and division, and press enter. Second division and press enter. It bears his name. He came up with it. He showed this thing with the E. So that's why they say, okay, Euler, E. Okay, so here's another situation. Limit x approaches infinity from 1 plus 1 over x raised to x. I need to identify what this is. When x approaches infinity, what do I get? Where does this go?
1 plus 0.
Yes, and this? Ah! So what do you think I'm going to do? I'm going to say let y be 1 plus 1 over x raised to x. And then I am going to do, okay. See how important natural log is? Okay. What do you think I'm going to do next? Find limit as x approaches infinity from natural log y, which is from this. Limit as x approaches infinity from x times natural log of 1 plus 1 over x. I need to plug it in again. Where does this go? Careful. Infinity. When x approaches infinity, x approaches infinity. And where does this go? So this is 0. Natural log 1 is? Good. So please make a note. 1, 2, 3, 4, 5. And no, you cannot say 0. And it will not be 0. Okay? So this is number 5. Indeterminate case number 5. Okay, perfect. I'm sad. Why am I sad?
Because you can't use L'Hopital.
Exactly. But I can do a little algebraic manipulation though. Limit as x approaches infinity. Natural log of 1 plus 1 over x over 1 over x. When I flip this, I get x. So am I allowed to do this? Yeah, because this over 1 over x is x times natural log. Now, can anyone tell us where the top is going? Where is it going for now? 0. Where is the bottom going? I'm no longer sad. I like it. So now limit as x approaches infinity from. I need to differentiate the top as if the top is by itself. 1 over 1 plus 1 over x multiplied by the inner function prime.
Negative x to the
Negative 1 over x squared. So let's differentiate so we remember this. This is important. So you agree that 1 over x is the same with x to negative 1? So when I differentiate x to negative 1, I have negative 1 times x to negative 2, which is negative 1 over x squared. Try, if possible, to remember that every time you differentiate 1 over x, you get negative 1 over x squared. It's very important when I get to chapter 5, because you should be able to come back from the right to the left. So that's natural log of a function is 1 over the function times the function prime. Now I differentiate the denominator as if the denominator is by itself. I already know how to differentiate 1 over.
It's just negative 1 over x squared.
And I'm sure you're going to allow me to simplify. And now please tell me what you get. 1. I'm going to look at the first and the last. So limit of natural log y is 1 when x approaches infinity. And yes, I'm allowed to swap the two operators, the ln operator and the lim operator, because all conditions are fulfilled of continuity. So natural log limit x approaches infinity of y is 1. What should this be? Right. So then I come back and I fill in the second possibility. Limit as x approaches infinity from 1 plus 1 over x raised to x. And that's the other option. So yes, this is E. So then I can go blah, 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 blah right here, and I know that this is E. So one more time, the indeterminate cases that we already looked at. 0 over 0, infinity over infinity, infinity minus infinity, 1 to infinity, and 0 times infinity. For now.
How many are there?
I think there is one more, which is
I mean, you say
0.
for now, like we have a whole bunch more.
No, there is 0 to 0. That's the other one. I think there's 6.
Wait a minute. 0,
0 to 0.
1 to
we
infinity.
want.
yeah. 0 to 0 should be 1. Well, should be.
Infinity to 0. Yeah. They are.
Special.
No. Let me just go back because I don't want to say something where L'Hopital's role is way in chapter 4, but I couldn't wait. Okay, we know 0 times infinity, infinity minus infinity, 0 over 0, 0 to 0. 0 to 0 is indeterminate. Here it is. And infinity, that's it. These are the old ones. Okay, so 0 to 0 is not 1, of course not. Infinity raised to 0, that's what I just listed. 1 to infinity. Yes, I think that's it. Yeah, these are all. So please add these two, but I didn't want to add them right now because we didn't run into them. So this is in chapter 4, so I would have added them then. But yes, these are all 6. So 0 to 0 and infinity to 0. Good. So we're back to, where was I? Yes, 3.7, rates of change in natural and social sciences. So at least a couple, let's take a look so we can star-related rates. Okay, I'm on page 234. Page 234. And 3.7, rates of change. The height in meters of a projectile shot vertically upward from a point 2 meters above ground level with an initial velocity of such and such is h, and I will say h of t, equals 2 plus 24.5 t and minus 4.9 t squared. So this is the height in meters. Okay. Find the velocity after 2 seconds and after 4 seconds. So part A, velocity after 2 seconds and then 4 seconds. How do I find the velocity? I'm given the height or the distance formula. This is problem 7 on page 234. So I'm given the height or the distance. Okay. I'll see you on Monday. How do I determine the velocity? I have the distance formula. How will I determine the velocity? Yes, very good. So h prime of t is the velocity of t. The derivative, the rate of change of distance with respect to time is the velocity. So then when I differentiate, I will get 24.5 minus 9.8 t. Excellent. We are asked to find the velocity after 2 and 4 seconds respectively, so I have to find v of 2 and v of 4. Oops. So I grab my calculator, 24.5, I'm lazy today, minus 9.8 multiplied by 2, and then I will repeat with multiply by 4. Okay, so I got 4.9 and then I got negative 14.7. 4.9 feet, no, meters per second, and negative 14.7 meters per second. Does this mean that the velocity is negative? No, it means that, yes, it means that depending on what you consider positive and negative, it's just the direction. So I could consider this direction positive and then this direction negative, but it doesn't mean that the velocity is negative. Just this direction of the velocity. When does the projectile reach its maximum height? So in part B, when, which means t equals what, does it reach its max height? Very good. So when the derivative is 0, how do I know that? First of all, we haven't discussed that. This is in chapter 4, more so than here. I know that this is a quadratic function, correct? It has a negative leading coefficient. So the graph of this function is this. It will definitely have a maximum. And we know that at that point of max or min, the derivative, because it's a horizontal line, right? The slope of this line is 0, so the derivative at that point is 0. So I have the derivative. This is it. All I have to do is set v of t equal to 0. So 24.5 minus 9.8 t is 0, so t equals 24.5 over 9.8. And this will be in seconds. 24.5, 9.8. This calculator never, when you turn it on, 2.5. When you turn it on, you have to wait for a few seconds. If you type in a first digit, it will not take it at all. 2.5 seconds. So the maximum height is obtained, or attained if you want, when t equals 2.5 seconds. What is the maximum height? Very good. What is the maximum height? So the maximum height will be h of 2.5 is the max height. I'll directly put in the calculator, and I have 2 plus 24.5 and minus, times 2.5, 24.5 times 2.5, minus 4.9 multiplied by 2.5 squared. And I got 32.625. 32.625 meters. When does it hit the ground? Question D. When does this hit the ground? What do we know about
values where, well, the solution to the,
how much is the height when the particle or whatever we have, a projectile, hits the ground? 0. So h of t is 0. When the projectile hits the ground, the height is 0. So then I have 2 plus 24.5 t minus 4.9 t squared equals 0. I have to solve this quadratic equation. What do you recommend we should do? Very good. First, I will multiply both sides by -1. 4.9 t squared minus 24.5 t minus 2 equals 0. So t equals negative b plus or minus b squared minus 4ac, but there is a minus already, so minus 4 times 2, which is 8 times 4.9, over 2 times a, which is 9.8. So I know you know this, but I'd like to show you. This is how I would put it in the graphing calculator. The top has to have left parentheses and the right parentheses. So 24.5 plus the square root. I'm old-fashioned, I have to put parentheses. They may not be required. So 24.5 squared and plus 8 times 4.9. Close the parenthesis, go outside completely, put a right parenthesis for the top, and divide by, in parentheses, 2 times 4.9. And close the parenthesis. And then I repeat by repeating the entry and going back to change the plus into a minus sign.
Should it be negative 24.5?
No, because there is another negative in there. Oh, when I square it?
No, the formula is negative. Oh.
Yeah, yeah.
Oh, it's already.
Yep.
Never mind.
So of course, one of the values makes no sense. So t equals 5.08 seconds and t equals negative 0.08 seconds makes no sense. Okay. Part, when does it hit? Okay, part E. With what velocity does it hit the ground? With what velocity does it hit the ground?
The derivative at the point that we just found.
Excellent. So I have to find V of 5.08. And where is it? 24.5 minus 9.8 times 5.08. So 24.5, if you have it, don't torture me, give it to me. So I can write it. Minus 9.8 multiplied by 5.08. And I got negative 25.2. 284 meters per second. Again, this is just direction. Any questions on this problem? Any questions? Any questions? I would like to look at least at one more problem, problem 20. Newton's law of gravitation says that the magnitude F of the force exerted by a body of mass m on a body of mass uppercase M is this. So I'm going to copy that. So this is 20 on 234. Any questions on the previous problem? Okay, 20 on 234. And this is F equals G m m over r squared, where G is the gravitational constant and r is the distance between the bodies. Find dF over dr. Find the F over dr and explain its meaning. What does the minus sign indicate? Okay, when I'm asked to find dF over dr, what does that mean? It means that F is a function of only one variable, and that variable is r. Since r is in denominator and these are three are all constants because this is df over dr, it means that f is a function of r and nothing else. Okay? So I could rewrite it as gmm times r to negative 2. It will be easier to differentiate. So now please differentiate and tell me what to write to find df over dr.
Negative 2g
Negative 2g mm times r
negative 3.
to negative 3, or negative 2 g mm over r to the third. Excellent. Explain its meaning. Well, we already did. Is the rate of change of force, gravitational force, with respect to the distance between the bodies. What does the minus sign indicate? That the closer they are, the smaller the force. They're right? So Newton says that the magnitude of F is force exerted by a body of mass. So the direction is the opposite. That's what it means. So the rate of change is negative. When the distance increases, the force decreases. Part B. Suppose it is known that the Earth attracts an object with a force that decreases the rate. So part B, dF over dr equals 2 newtons per kilometer when r equals 20,000 kilometers. How fast does the force change when r is 10,000 kilometers? Let's read the question one more time. Suppose it is known that the Earth attracts an object with a force that decreases at the rate of this. By decreasing, we mean this. When r is 20,000, now we're asked to find this when r is 10,000 kilometers. Very good. We do have the dF over dr. We have an expression for dF over dr. So I'm going to set this equal to this. So negative 2 gmm over r cubed must equal negative 2 when r is 20,000. I will simplify. And then it turns out that gmm is 20,000 to the third power. I'm going to raise 2 to the third power, and I'm going to say it's 8. 1, 2, 3, 4. 10 to the fourth to the third is 10 to the 12th power. So this information was really given to us to determine this product. So I know that gmm equals 8 times 10 to the 12th. So now I'm asked to find dF over dr when, and I know the formula, I have the formula right here, but when r is 10,000. So I have negative 2, I have gmm, which is this product now, 8 times 10 to the 12th, everything divided by this, there are 4 zeros to the third, so this is 10 to the 12th. Negative 16 newtons per kilometer. Any questions? Any questions? Questions for me? I'd like to look at least one more application here, like 31, on page 236. But let's see if we have any questions on this problem. Any questions on this problem? Is this okay? So obviously the closer the object to the Earth, the force is higher. Okay, 31. Let's read 31. The cost in dollars of producing X yards of a certain fabric is this. Find the marginal cost function, find C prime of 200 and explain its meaning. What does it predict? And then compare C prime of 200 with the cost of manufacturing the 201st yard of fabric. Ready? So I'm copying the function C of X equals 1200 plus 12x minus 0.1 x squared plus 0.0005 x to the third. Find the marginal cost function. Ready? The marginal cost function is the function that gives us the rate of change of cost with respect to the number of units. So this marginal cost is C prime, which is 12 minus 0.2x plus 0.0015x squared. In part B, we're asked to determine, find C prime of 200 and explain its meaning. Okay? So how do I find C prime of 200? So 12 minus 0.2 times 200 plus 0.0015 times 200 squared. Okay, lazy today. So 12 minus 0.2 times 200 plus 0.0015 times 200 squared, and I got 32. Measurement unit, first of all. So this is the marginal cost function at the production level of 200 units. So this is the marginal cost function at the production level of 200 units. But the measurement unit, we have not written the measurement unit. 32 what? Remember, this is always a rate of change. So the measurement unit has to be a ratio of two measurement units.
So cost per unit?
Very good. Very good. That's the marginal cost. In part C, compare this. So we are asked to compare this with the cost of manufacturing the 201st yard of fabric. How do I determine the cost of manufacturing? That's part C. I have to find the cost of manufacturing the 201st item or unit. This must be, and I'd like to discuss this for a minute before we decide what to write. We know the answer, but I need to discuss this for the next section anyway. So here's a function. This is 200. Maybe I should just put C of x. This is 201, and this, of course, is 1 unit. Can anyone give us this value? Well, C of 200. Can anyone give us this value?
Yeah.
Right. So what will be the cost, the additional cost, if I manufacture 201 instead of 200?
So don't you like subtract them?
So this will be C of 201 minus C of 200. What does C prime, before we determine these, what does C prime of 200 represent?
The tax, the price?
Right, but here on this graph, how will I present C prime of 200? What does that mean? the rate of change of C when we produce 200. So what does that represent here? How will I graph that number here? What does it mean? The rate of change when X is 200. That is the
Tangent.
slope, right? So this is C prime of 200, which is 32. Of course, dollars per unit, right? Okay, so we are comparing basically this slope, the slope of this line, which is rise over run, but since the run is 1, this number here is 32. So I'm comparing 32, which is this, which is huge and large for me because I need to show you what I'm doing, but these are very, very close, right? So the distance between this and this, which is 32, will not be this big, but I have to graph it as big as possible so I can tell you what I'm. So we are comparing this to this. One more time. The slope of this line is 32. But this is the same with rise over run. Rise is whatever, but since run is 1, the slope of this line is this measure because this is 1. Now I have to determine this difference. Let's determine this difference. So C of 201 minus C of 200. And of course, I don't longer have the function. So I have 1200 plus 12 times 201 minus 0.1 times 201 squared plus 0.0005 times 201 cubed, and then minus 1200 minus 12 times 200 minus plus 0.1 times 200 squared and minus 0.0005 times 200 cubed. I'm checking my writing here. So this is plus, plus, minus, plus. So then it's minus, and then it's minus, and then it's plus, and it's minus. Correct. So I want to find this number. What should I get? 45? 5? No. What should I get, really? Close to what? I'm comparing this distance to this distance. So what should I get? Close to
0. Well, wait a minute.
I will determine this number, and I have this number. From this point till this point, I have it. But now I'm trying to determine the exact, which is between this point and this point.
So we close 32?
Of course. Otherwise, math means nothing. Of course. It has to be close to 32. This is an approximation because I used the derivative, right? But this will be the exact. But which one would you prefer?
The exact.
You would prefer the exact, but look at the calculations.
So the derivative.
So I would prefer this as long as this is very close. Now, if the difference is 10 units, then I don't want that, right? But it's not going to be. Okay, so I'm just punching in the calculator now. Of course, these two go away. 12 times 201 minus 0.1 times 201 squared plus 0.0005, 3 zeros, yes, times 201 cubed. I'm here now. Minus 12 times 200 plus 0.1 times 200 squared, and then minus 0.0005 times 200 cubed. 32.2005. Isn't that math great? Of course, dollars per unit. So when I determined this, I knew that this was an approximation. When I determine this, I know that this is the exact. But look at the work for the exact. And look at what's at stake. 0.2005 per unit. Very good. Any questions? Any questions here? Any questions?